Hi, welcome. This is the March 24 meeting of the Kubernetes IoT Edge Working Group. Uh, because this group operates under the Kubernetes project, we abide by the Kubernetes Code of Conduct. The summary of that Code of Conduct is just be nice to each other. Also, under the Kubernetes projects, all meetings are public and recorded. So this meeting will be published on YouTube. If you don't want to be part of that recording, your options are to drop now or to turn off your microphone, camera, and change the name in the attendees list. I'm going to put a note to the meeting agenda and notes document. So I'd invite everyone to add their name to the attendees list. And you could help out if you like. All members have edit rights to that document. Anyone is welcome to help keep notes. So for today's meeting, we've got a guest speaker coming in, but he had a conflict at the first half of this meeting. So he's going to be joining us about 30 minutes in to speak about the LFEdge project, LFEdge Foundation's Project EVE. Before we get to that, we'll fill time with just free-form built birds of a feather discussion of whatever members want to talk about. I'm going to commandeer the first part of what members want to talk about and bring up the fact that KubeCon Europe is coming up soon in May. And as part of KubeCon Europe, there is a pre-event called Kubernetes on Edge. Jan and I have been working on the program committee for that, and the schedule is now published on a day full of sessions dealing with Kubernetes and Edge. So I'd invite you to take a look at that. There is a link to it in the agenda notes document. Jan, do you have anything to add?
No, not much. So, yeah, please take a look at the schedule and, yeah, join the event.
Okay. If anyone wants to bring up a topic or question, request for help, just jump in there and speak. Also, if there's anybody who's new here, who has never been to a meeting and wants to simply introduce yourself, go for it.
Hi, I'll go. My name is Aaron Williams. I'm the dev advocate for LFEdge. And I will say the other gentlemen who have joined are also, from Project EVE, which is one of the projects underneath the umbrella. I'm really here. I'm here just to kind of learn more about what you guys are doing and to kind of pull that information into the wider LFEdge community. Make sure that we can communicate and don't do duplicate things and things like that. So,
okay, since you're new, maybe we should just go all around and introduce everybody. So I'm Steve Wong. I'm a software engineer with VMware, and I've been a tech lead in this group for over 2 years. The group is charged with dealing with helping users apply Kubernetes for edge use cases. So this group doesn't own code in the Kubernetes project, but we're in a position to listen to user requests and put on materials that would help Kubernetes be applied for edge. The scope of that has been traditionally that there are some people who have an edge use case that is pretty full in compute resource such that they can run a Kubernetes cluster at edge. There are others kind of in a transitional phase where they might run a split Kubernetes cluster that has worker nodes at edge, maybe a control plane, a little more centralized, perhaps in a regional center, perhaps in a public cloud. And then finally, there is a form that people are applying of utilizing the extensible nature of Kubernetes to write CRDs that would manage to run edge devices that are not Kubernetes cluster nodes at all. And I don't think I don't think it's emerged that there is any one right answer out of those three flavors. There are people doing all of them. And because these use cases vary quite a bit in what they're trying to do and the resource available, I personally don't know that I'd expect that those ever consolidate. It's just legit to have those three forms of Kubernetes. So hopefully that fills you in a little bit about what this group is about. Dan, do you want to go and say a few words?
Yeah, I mean, same here. I'm an engineer with Red Hat and been involved into bootstrapping this working group and for the last couple of years. And yeah, we are basically here trying to tackle all the use cases where we can use Kubernetes for the IoT and the edge use casing. That story evolved over the last couple of years, and it would be great to see, you know, what you guys from LFEdge are doing to, you know, and how we can work together, basically.
Maybe if somebody from LFEdge wants to be a spokesperson and describe to us kind of the scope and mission of LFEdge and how it might relate to Kubernetes.
I think this is perfect timing for Jason to chime in. Jason,
yeah.
on,
Sorry,
right?
I was muted. Yeah, so let me talk about that real quick. How much do you guys know about LFEdge? Like, how 101 should I go?
Well, let's make it vary, because it's not just us. We have people who are going to perhaps catch this on video on YouTube later.
Yeah.
So
okay.
I don't think anybody who already knows it would be offended by hearing it again. So
yeah,
let's get the 101.
Let me pull up a different slide that's got more of a high level overview.
Let me make you a co-host so you can put that slide up.
Okay.
Okay, you got it.
Okay. Hold on one second. Okay, here we go. So, you know, obviously, you know, it's a sister umbrella organization to CNCF, focused on edge. Let me pull this up.
Okay, we can see that.
You see my, yeah, cool. So yeah, focus on edge. You know, very similar to CNCF. It's focused on kind of the continuum of edge, and that's something I think we should kind of talk about when you guys reference edge. You know, what's the scope? Because as you guys know, there's not one edge, and so we'll come back to that. But all about driving consolidation around kind of common frameworks for edge computing, covering the spectrum, series of projects. You know, again, very similar to CNCF. There is some overlap between projects, but at the same time, the goal is to start harmonizing things, you know, in the future. And there's also some unique trade-offs depending on what you're doing. And so, you know, across the continuum of edge, there's just inherent trade-offs. Technically, that's how we define the taxonomy. So I don't know if you guys have seen that, but I'll give you the gist of it. If you go further left from the cloud, everything gets more complex. Hardware, software, skill sets, you know, everything closer you get to the physical world. So kind of high level project summary. So Crano is a little bit different than the other ones. This is about creating solution blueprints, kind of initially a telco focus, but that's moving left a bit. They've been collaborating on some blueprints with CNCF, as you guys might be aware. But definitely a little different. Some API definitions, some code, but mostly more about those blueprints. You know, we're going to talk today about EVE OS, which is part of Project EVE. And we've been bridging to Kubernetes, and we'll kind of talk about the trend there. There's other projects. Open Horizon is a container deployment mechanism, but you know, probably more complementary to EVE-OS than not, because this is a agent-based solution. EVE-OS is a bottoms-up bare metal solution. So we'll talk about that. Each project is at different stages. So Betel's contributed by Baidu as a stage 1. That's kind of more around data, a little bit more around data analytics and bringing data into the cloud. LFEdge is focused on sort of developing home appliance servers for appliance-based servers for server-based appliances for home use cases, surveillance and natural language processing and whatnot. And then there's 2 IoT data stacks that you might be familiar with. I actually helped get EdgeX Foundry started, launched in 2017, and that's been growing. But then LFEdge is another application framework for IoT workloads. LFEdge is more optimized for industrial. EdgeX can do industrial, but it's more general purpose. There is overlap at the same time. LFEdge is, there's trade-offs. LFEdge made the trade-off for more compact, higher performance, but less modularity. EdgeX is super modular. And so at the expense of, less performance, but good for soft real time. So working on kind of consolidating and creating alignments, it takes time, as you guys know, in open source, the cream rises to the top. There's a couple other projects not represented here that have come in, at least one actually, Intel's secure device onboarding project that wasn't here, and I'll share this with you guys just so you have it. I mean, there's obviously a lot of stuff online as well, but so that's the mission. Stage 1 is I think this was borrowed. I don't know if this is from CNF or another project within Linux Foundation, but stage 1 is at large. You get the hosting of it. Stage 2 is where you start getting some marketing benefits. Stage 3 is where these are well on their way, and you get the most benefits in terms of funding and whatnot to further grow the project. Normal technical advisory committee, all the kind of normal setup you would see in an umbrella project.
Okay.
Makes sense in terms of structure.
Yeah. Is the Intel project officially in now?
Yeah.
They presented to our group a couple months ago, so that's interesting to know. Also,
yeah, it's not on that chart, but yeah, it's in here as a stage 1.
Also, just in terms of scope, like our group scope is that it has to involve Kubernetes. But other than that, we're pretty broad and open to all flavors of edge use cases, whether it be industrial IoT or what might be called retail edge. We're kind of not attempting to restrict the scope and stay general. But in LFEdge, the words LF, I assume, are attributable to Linux Foundation. Are you restricting your scope to things at Edge running Linux, or is it open to other OSs as well?
It would cover, covers everything, and that's why we think EVE-OS as a foundation, even for Kubernetes, it just makes a lot of sense. We would, your security white paper that you guys put out, it literally all the things you guys talk about, which is totally accurate. That's what EVE-OS is architected for. And we'll walk through those benefits. Eric and Roman, you can get deep into the technology, but real quick, so level setting. Obviously, there's centralized data centers. There's evolution of tools, but pretty well established. On the far other extreme, you've got super constrained devices that are highly embedded. A lot of people from the IT world say, "Oh, all compute's happening further upstream, and kind of creeping down." But we're seeing tiny ML in lightweight devices, more fixed function, but the way this white paper, if you haven't seen the LFEdge white paper that we put out last summer, it's a pretty good read, and it goes through. There's near edge and far edge, and people say thick and thin, or they say industrial edge, retail edge. There's one continuum, and you apply different tools and considerations, domain knowledge, and that's it. The categories here are based on 3 inflection points. One is it on a wide area network or a local area network relative to the users or devices it serves, that compute. If you're on if you have a latency critical workload, you will never ever put it on wide area. I don't care how fast your 5G stuff is, you're not going to do your airbag from the cloud. Not going to happen. The next one is, are you in a physically secure data center or are you not? So that's where this on-prem data center is. This is your traditional on-prem, could be micro modular data centers. Once you get out of this, you're now accessible. Very different considerations. And the last trade-off that the paper goes through is, are you capable of abstracting hardware complexity with VMs or containers? Or is it so constrained, usually driven by memory, that you have to go embedded? Everything gets way more complex at that point. Those three inflection points, is how we define the continuum. And the way that we're looking at it is, and if you kind of look at the base, EVE. So you got like Linux Foundation projects. Of course, there's more stuff out there, but in terms of kind of example projects, open source projects, Zephyr is focused on constrained device edge. It's an embedded, kind of RTOS. You have to embed per that. EVE OS, the strategy in that community was start with the lowest common denominator, go to the hard stop on the left, driven by memory, before you just can't support, that abstraction anymore. It's a technical trade-off. And then EVE OS, support legacy workloads, do the zero trust security. We'll talk about all those benefits. Start at that lowest common denominator, and then you're gonna see bleed up to these higher, thicker edges, so to speak, the service provider edge or on-prem data centers. Of course, you guys know that Kubernetes, both K8 and K3 are moving left, but they start to you run into challenges once you start getting into that scale factor. You get into the outside of the data center or at the fringes of the data center, all the stuff that you guys have been kind of documenting as a team for a while. And so what we're doing with EVE OS is that we're intersecting the Kubernetes trend. And because EVE OS supports both virtual machines and containers, again, we'll go through the architecture, but it's got an embedded hypervisor in it. We can drop Kubernetes runtimes directly on EVE OS and you're done. But meanwhile, you can support native Docker containers. You can also support, there's a lot of legacy out there, as you guys know, people are like, I need to deploy a Windows existing app right next to whatever. And so it's start with that lowest common denominator security foundation, and then meet the data center tools as they come down. And we're right at that phase. We're actually about to launch, that kind of formal support for Kubernetes, which is why we wanted to, meet with the team, here. So does that make sense, kind of in terms of the continuum and what we're seeing in terms of that convergence between like that base and the IT tools coming down?
Yeah, that does.
Yeah.
Definitely.
Okay. Yeah, cool. So I'll kind of high level benefits. I've already talked about some. And
Yeah, maybe we can wait, because I told people in our Slack channel the EVE presentation would start at 30 minutes, just in case somebody postponed. But we can cover LFEdge in general, and if anybody else has got any questions to jump in with right now on LFEdge.
Yeah, it might be good too. Yeah, so questions on LFEdge, it might be good too to, for us to hear a little bit about kind of the work output that you guys have had since you formed. We've seen the security paper. I've seen a number of the presentation you guys have done online, but a little more info would help. And then we can get really get into it when people join in. But questions on LFEdge, we'll start there. Yeah, so clearly there's not one pattern. You're not going to see everything go through the continuum. This is also from the white paper. You'll see device to cloud and gateways, stuff running at the service provider edge. The way we defined it, those two big buckets, user edge tends to be owned and operated by end users. Could be devices that are owned. The smart device edge, we purposely chose smart device because, well, number one, intelligent edge is branded by some vendors, but this includes mobile devices, PCs, client stuff, and headless things for IoT, so gateways, hubs, routers, servers. The mobile side and client PCs, that's a solved problem. Windows, Android, iOS, whatever. The rest of it, Wild West. It's very, very fragmented, and the point with EVE OS is to create that universal base that meets all of the needs for that and then expands up. So other questions on LFEdge. Let me see if there's any other kind of relevant stuff. Growing as a community, so growing in members and deployments. EdgeX actually just hit I think 7 million downloads by now, so it's definitely growing. Bunch of members and all that. So other questions? Anything else we can kind of cover as we wait for the people to join in? Eric and Roman, you got any kind of background that you'd like to share?
No, I think you've sort of nailed it.
No, I mean, I think that. Go ahead.
No, I was just going to say, I mean, I guess my only question is, since I'm not familiar with this working group sort of, progress so far, would be interesting to know, like, if there's anything that, is sort of coming down the pike, so to speak, on your end, guys.
Well, let me just go over the history of this group. I think in the early days, we started out with a lot of inquiries and presentations on dealing with running Kubernetes in a resource challenged environment. If you're in a large data center with rack mount computers, Kubernetes was made for that, and it sort of just works with default settings. But as you move down to lower resource, you've kind of got to go and tweak a lot of configuration, both on your worker cluster nodes as well as the pods themselves, to have them declare what the resource demands are, and to enable the Kubernetes scheduler to do triage when resources come up short, so that the higher priority ones really do keep running, and the lesser priority ones are the ones that take the bulk of the suffering if you don't have enough resource to go around. Then the group seemed to morph into collateral issues like the unique challenges of network connectivity at edge. Early days, we were home to some of the discussions of things like the LFEdge project, but they eventually got accepted into the CNCF as their own independent entities. We also hosted presentations on some of the lightweight Kubernetes distributions, MicroK8s and K3s. But once again, I think they established enough of a base that they are freestanding on their own to a large extent. But this group, I'd like to think, was a contributing element to those things in the formative stages by helping them build community and awareness. So this group is kind of a generalist attitude of helping users apply Kubernetes and not focused on any one thing. By design, we're trying to cover kind of the broadest possible scope, limited only by the fact that Kubernetes should be involved in some way, because we are part of the Kubernetes project. And I think in the last year, the new trend is this approach of using Kubernetes custom resource definitions, an ability to plug into the Kubernetes control plane and API to extend it, to use it as a control plane for things in general, that has really been gaining traction. And this is what allows it to be potentially viable as a control plane for just bare devices of any type. Really, by any type, I mean it, any OS, any scope, from the tiniest embedded systems to full container runtime hosts. Dan, do you want to add anything there too?
Yeah, so, and I think you covered the history pretty well. So what we'll also be doing lately is, at least from my perspective, focusing also more on the wider CNCF landscape for doing IoT and edge computing. So we dealt a lot with the K-native eventing and solving kind of how to fit those frameworks for building applications for the edge and IoT. So that was the topic for the last, I think, two sessions that we did for the KubeCon, right?
Yeah, I think people are becoming aware of kind of the challenges of using a traditional data center approach, like TCP connections with TLS, maybe not being well suited, perhaps not well suited at all for time series data and low latency and a number of issues like that. Even traditional Ethernet transport is something that in some of these edge use cases just isn't an appropriate fit so that supporting things like event-driven message queuing protocols and things like that are something that users are very much interested in. And there's the potential to use Kubernetes as a supervisory control plane in those kind of environments. Kind of, if you viewed it as what happened in the data center of something like Service Mesh being an easy button for not requiring every one of your developers to be a network expert and a security expert at the same time. If there was a way to put that together to enable secure, reliable communications for edge devices, I think the world is crying out for such a standardization effort. It isn't coming together at this point, but we've had a lot of discussion about it in this group.
So this event thing, is that trying to target or address the issue that the network might be intermittent out at the edge, the connectivity back to the cloud and to other components? Or
yeah, it would help tolerate intermittent networking, and some of these networks are intermittent by design. It isn't necessarily reliability, but maybe power consumption, and it is a way to deal with this. But more importantly, I'd say even deal with asynchronous connections between applications and services, such that they don't require permanent low. Some of these don't require low latency connections up to the higher levels. They just require eventual delivery of these things. And the CNCF is hosting a number of projects that deal with this eventing, like Knative eventing, cloud events. I don't know. There's actually a whole category that has come under CNCF fostership, and it plays nicely with these edge use cases. So a lot of this has been, I would contend, an integration effort.
Okay. Yeah, because we've sort of been looking at that more from the infrastructure side in EVE, right? Which is, okay, we need to deal with eventual consistency when it comes to, I don't know, applying patches to Linux, right? For instance, right?
Mm-hmm.
You want to make sure that they get completed reliably and securely, but if this thing is, not reachable this hour or this week, well, it will still happen, right?
Right.
But the application layer, yeah, if people are just used to, I can always stay connected, well, those applications are not going to work across the whole edge, right? Because it depends on connectivities.
Yeah, there are some of these connectivities, I don't know, like LoRa, that might wake up in a microamp current consumption embedded device. By design, they may wake up once a day or once an hour, and you opportunistically take advantage of your connection while you can. And eventing tends to play nicer with that than trying to run a TLS connection.
So one question about the security sort of issues white paper. I've read that thing, right? Is that something that you guys are pursuing any further, or sort of are you guys trying to make the larger Kubernetes community aware of those issues out at the edge, or what's happening in that domain?
Well, I think at one time it was a very active thing we published, and maybe had an aspirational goal of keeping it as a living document. But to be honest with you, it took quite a bit of work to bring that thing together, and we haven't gone and revisited it yet. I thank you for the reminder that we probably, after having published it, we should schedule perhaps a once every year or once every 6 months revisit, because like anything in technology, it should be published with a sell-by date. And to be honest, I haven't taken a look at it lately, but I'm suspecting that some parts of that have become stale.
Well, it's also sort of, as a checklist saying, okay, where are we at, right? Are we making progress on these pieces? Yeah. And, I think that some of the things that we've done in and around EVE is addressing the lower layers of the stack, right? Sort of secure boot, remote attestation, whatever type things.
Right.
And networking pieces as well. But then sort of the application side of things, that how do I know that this is actually the workload I'm supposed to be running, right?
Mm-hmm.
Right. I don't know if there's work in the Kubernetes community around that level of validation.
Yeah, I Kubernetes has gotten so big that I can't contend that I know where everything lives, but there is validation of kind of the Kubernetes compliance itself, which would be the base Kubernetes. But the bigger picture of validating, I don't know, container images would have fallen off into image registries. And they most definitely do have policing of the provenance of the image, how it was built, who got their hands on it, as well as looking up the components and mapping them into CVEs. But that stuff, at least from my perspective, is spread all over in a number of homes. There isn't some centralized authority that has taken control over it. And I'm not saying that it's bad that that doesn't exist, because there'd be a trade-off. But yeah, I can't contend that I know that there's one place to go with the broad scope of Kubernetes that would tell you everything you need to know about how you do security.
Yeah, let's dive into the, I definitely could see that. Let's dive into just kind of the overview and then keep it conversational. For those of you who weren't hadn't joined yet, I know there's a recording, but
yeah. So go ahead and take over in the Project EVE.
Right. Yeah. So we're gonna talk about EVE OS and how, as a community, we've architected it to go to the lowest possible common denominator for edge hardware before you just have to go embedded. And a lot of the stuff happening in CNCF, great stuff, but it's presupposing you're in a secure environment and the controller is talking with the clusters, and the controller reaches out to the clusters, kind of more traditional data center approach. Whereas, as we were saying around the need for autonomy, EVE OS assumes you're going to lose connection, and the box always phones home to the controller, and it's got an eventual consistency model, which we'll talk about. So it's designed to be universal, including supporting legacy, meet the needs from a security standpoint, many of which you guys have uncovered in your work. Lots of legacy out there. That need for autonomous, the fact that it's bare metal, you can't brick devices. There's a number of agent-based solutions, both open source and commercial for IoT, edge computing that don't, unless you spend a lot of time trying to integrate with the OS, you're going to brick the device at some point. And then they're all container-based in many regards, and a lot of things, including Kubernetes, benefits being deployed in a VM on top of that bare metal foundation. Completely open APIs. Think of EVE OS for Edge as what Android did for mobile. Create an open foundation, completely open APIs, abstract hardware complexity, and then enable an ecosystem of hardware providers and app providers to build around it. We've got EVE OS being adopted right now from a lot of hardware providers, HPE, Dell, Lenovo, Advantech, Supermicro, Lanner, and app providers love that because they don't have to touch it. Exactly the same model as Android from a standpoint of unifying that device makers on the south side and app providers on the north side. So in terms of architecture, I can let Eric and Roman can run through this quickly, but very much curated for these types of edge nodes in a variety of ways. Eric or Roman, I don't know if you guys want to kind of dive in on some of the keys. I know this is just a high level, but.
Yeah, no, absolutely. I mean, I just, maybe will highlight a few things and let Eric, talk in more details. But I guess, the way to think about EVE OS, specifically in the Kubernetes context, right? It's all of the missing stuff that people somehow assume, is just there, that basically needs to be there for Kubernetes to run. And we've seen a number of these operating systems, right? Ranging from CoreOS. I mean, the whole mission of CoreOS was to basically be the missing, link between the Kubernetes and the hardware, right? Then there is Talos. There's a few others. I mean, obviously there is a spiritual successor to CoreOS, which is, the flat car. So I mean, there's clear need for that type of an operating system, right? And that's, one view that one can take on EVE. The other view is actually much more in line with the original mission of, CoreOS, which is, Kubernetes might not actually be the only workload, right? And to Jason's point, for us, it mainly means legacy, right? Just running an occasional Windows application, or something like that. But at the end of the day, it's all the missing stuff that otherwise, as a customer, you would be asking your system integration company to do for you, because none of it is available out of the box, right? And it's kind of like, this Android analogy, right? It's like, yeah, I mean, you can probably deploy, Red Hat or SUSE on your Samsung, phone, right? But that wouldn't work because, well, I mean, that wouldn't work out of the box because you would still fight with device drivers and this and that. And like, a skilled system integration, can address all of it. But then you're basically doing this, completely undifferentiated heavy lifting every single time you're trying to deploy just a single app. So EVE is trying to sort of fill that gap, very neatly. It's a very small operating system, unlike some of the alternatives like, traditional Linux distribution like Red Hat or, Ubuntu or, SUSE. So the entire EVE, takes 250 megabytes worth of storage, right? For a single partition, we actually do dual partitions. So for resiliency, but a single sort of image is just 250 megabytes, which, for example, allows us to basically net boot, and we can potentially even net boot over the wireless connection or something like that, right?
Is it okay to jump in with questions, or would you rather take them at the end?
Yeah.
So a couple come to mind. So you're landing on potentially bare metal or a VM that looks equivalent to bare metal.
No, it's always bare metal.
Okay, and then
getting in the root of trust and all that.
And taking charge of updates to the OS itself in a way that is brick resistant. Are you x86 plus ARM agnostic as to what the actual hardware is, or not?
That's right. Yes, we are. We're also looking into RISC-V at this point.
Okay, and
got it running on GPUs like nano boards, stuff like that. So it's definitely still looking independent. Sorry, go ahead.
And are you actually hosting a mechanism to also update the lower level bootstrap firmware, or maybe any supplemental any firmware associated with supplemental hardware devices like SmartNICs, I don't know, storage controllers, whatever, sometimes also have a need to get updated?
Yeah, we have, we have that architectural capability. We do some of it on ARM. We don't do as much of it on Intel, but, there's a few customer requests. Actually, they came from, Dell, when Dell had the gateways, product line, right? But since, Dell sort of gave up on its own gateways, that didn't really go anywhere. But yeah, once those requests come in, the architecture allows you to take care of the, those levels as well.
Yeah, and there's some things, like BIOS update, for example, like some users ask for it. If you have, it's usually based on hardware, the way they do it, like capsule update, for example. If there's that, then you can certainly do it, and there's ways to orchestrate that. But it's also, depending on where these devices are, sometimes not advisable to update things like BIOS unless you really have to, because that's when you definitely, of course, can brick the device. So if it goes wrong, but yeah, there's a number of different things architecturally that can be done, but certainly EVE OS, updating it, any of the guest applications, on top, and then as we said, it's designed to lose connection. Basically the way it works is you take EVE OS, you put it on a box, it taps into root of trust on the box, like a TPM, it creates a crypto-based ID based on that TPM or those credentials. Now you can no longer log into the box anymore, because that's one of the attack vectors where bad things happen, when people just kind of log into the box and start doing things. You can then also use the APIs to shut down any ports that you don't want access to, like shut off all the USB ports, for example, remotely, because it's bare metal. Then that crypto-based ID is what you use to log into the controller. Zadita, we are an example of someone that we have a cloud-based SaaS subscription that uses it, but anyone can go develop this, and we're seeing other people looking at that because of that open API. You're not locked in any particular one. There's a basic open source controller in the project, and we're looking at ways to kind of grow that, because everybody wins if we make this the Android of the edge. But at that point, you basically connect power networking, bootstrap it, secure dial tone to your controller, and you leave. everything else can be done remotely at that point, whether it's deploying Kubernetes or any other kind of combination of apps. Also really important in the industry. So clearly everyone's kind of moving towards this clustering, there's a big Kubernetes trend, but not only is there a lot of windows out there, whether it's in manufacturing, retail, point of sale systems, HMI, SCADA, yada, yada. There's a lot of industrial players, or a lot of players in general, that they pre-qualified a Linux image and they don't want to change it. This is my image. And the beauty of this is that they can run it on top in a, kind of call it in a VM, and even the drivers within it virtually pass through EVE OS, the virtualized IO, and it's like EVE OS isn't even there. And so, common paradigms that you would see in certain data center applications, but, really built from that ground up to meet that paradigm. It makes sense, and we can kind of get into some more details, but.
I mean, in another sort of perspective, right, depending on how people are coming at this, if you're coming from the data center, you typically don't think about this, but the fact that there is, baseboard management controllers, management networks, PXE booting, right, maybe remote power control, right, there's, if things actually go haywire, you can always reset things and restart in the data center, right? People that have deployed things at the edge, they've had these things, going back a couple of years when they did a demo in Chicago and they had to go rent the cherry picker so someone could get up to the light pole and press the reset button. That was all they had to touch, right? And basically the underlying EVE OS, it's not only the security functions, it's also that sort of robustness function that the device can always talk to something over the network that can tell it what to do, and it always gets back up, right? As long as the hardware doesn't break. We can't deal with broken hardware, but it's sort of building that infrastructure without assuming a separate network or other connectivity, just using the same connectivity as you have.
So in the diagram where you're showing Kubernetes running on top of EVE, is that hosted in a VM then, or is that a Kubernetes cluster node that is directly installing a container runtime on EVE OS itself without a VM wrapper?
I mean, by default, it's hosted in a VM, but we can basically, because we're actually using containerd ourselves, right? On the bare metal, I mean, we can potentially proxy that into the VM. Those requests actually never came. I mean, we sort of architecturally made it flexible enough, sort of thinking that people would be asking for Kubernetes on bare metal. Those actual requests never came. And, I guess I have public cloud to thank for that, because they sort of conditioned everybody that VMs are okay.
Yeah, and it could be that the VM would be a useful additional security barrier of some sort to protect EVE OS itself from evils that might link in from the Kubernetes world, if there were such things.
And other apps. Go ahead, Eric.
Yeah, if you want to deploy multiple apps, I think that was what you're about to say, it also protects in that direction, right? Multiple separate apps. You have a Windows VM sitting next to your K3S. They're isolated from each other, but also in the sense that EVE actually can provide some firewall and VPN functionality that's external to the workload you're running, the VM you're running. So now, your VPN configuration, even if your application is broken into because it's talking on the network, well, you can't break the VPN. So if the VPN is constraining it to only talk back to a particular cloud provider, okay, it can't escape out of that. Right?
Does EVE OS have a provision to allow things in the application level or application ring to get direct access to devices? In Kubernetes, sometimes this comes around where an app running in a pod really wants to deal with, I don't know, anything from a NIC to some sort of a USB hardware device. And there are ways that might allow you to not have the base OS of a cluster node claim it and pass it through. There are potentially security risks involved with allowing it too, but you can put it together if you want to. Is there a way to do that with EVE OS?
I mean, there's two ways to answer that question, right? First of all, since we're predicated on hardware-assisted virtualization, you can do the device assignment to a VM. I mean, that's easy, right? So even that VM that runs, K3S can get all the devices, as long as they're PCI devices, and even some additional devices that are easy enough to pass through, like serial ports and USB controllers and whatnot. So we have customers using GPUs, obviously, and that works very well. And the beauty of it is that it's a true pass-through, right? Unlike what I've seen in some of the proposals around, container ecosystem. At that point, EVE-OS is just completely hands-off, when it comes to that device, right? The VM that you've built for your K3S, deals with the device driver, and that's about it. We can do one better. We can actually do, full-fledged virtualization, and it's helpful when you actually have proprietary device drivers, which is, a lot of times the case on platforms like, Jetson, from NVIDIA, because with Jetson, for example, you end up getting a Linux kernel that is really, incompatible with some of the Kubernetes requirements. And there's nothing that you can do about it because that is the only Linux kernel that would support, the drivers from NVIDIA. Now, in EVE, you can actually put that into a dedicated VM and then virtualize out of that VM and essentially have what's in Zen, land is known as driver domains. So that, it's a VM that hosts just a particular driver and nothing else.
Okay, thanks.
Yeah, other questions, kind of about the overall approach? Yeah, so part of the reason for reaching out, I just kind of wanted to learn what you guys were doing. We are about to ramp up Kubernetes messaging, FYI. Middle of kind of third week of April, we're starting to kind of announce support, kind of that bridge to Kubernetes with EVE-OS. We're working with some providers like Rancher, now part of SUSE, in terms of their managed commercial runtimes, being able to run on top of EVE-OS. Of course, it could support any sort of open source effort. So there's just a lot of activity that's about to spin up as kind of more and more people are like, hey, I want to use Kubernetes at the edge, but there's unique challenges, as you guys know. And so if you want to operationalize it, you need the right foundation. We're also getting EVE-OS baked into other reference architectures within the industry, for the same reasons, in terms of the universal approach. There's stuff like around oil and gas, the open group. We're working with LFEdge, some other consortia. Just again, it's all about, everybody wins if we get to a more common foundation, lowest common denominator, and then we kind of bridge paradigms. So other thoughts, questions? We'll send you the stack and kind of let you guys chat and however we can help. But we'd love to create a bridge to the work that you guys have been doing and CNCF more broadly speaking, because we think there's a lot of value to help bridge that Kubernetes story out into the field. James, also, from a Red Hat perspective, we'd certainly be interested in talking about potential to make some bridges. Any other questions, thoughts? Last call? All good?
Oh, this sounds good.
Yeah, and just so as a community, we're approaching 60 unique contributors. Good growth curves. Obviously Zadata, we contributed the code, but the measure of any good community is it's not just you contributing to it. And so this year, not just the Kubernetes, there's increasing ARM and GPU support. Even though it's silicon agnostic, it always gets a little trickier when you get into the fragmented ARM ecosystem. But always looking to optimize the footprint, and then other industry efforts between CNCF and beyond, or Linux Foundation and beyond.
Maybe this might be later in your deck, Jason, but maybe if you can give us some clues on how we would get started. Like, suppose I wanted to just try this out, proof of concept on my own hardware. Where would I go for a getting started thing to run it on? I don't know. I assume it might run on a Pi or on a low-end NIC like x86, and maybe fill us in on whatever community meetings and Slack channel and ways to get involved.
Aaron can help with that. He dropped some stuff, I think, into the thing, and we can follow up with that. You know, Aaron, if you could follow up with that. Yeah, and as any self-respecting open source project, you know, there is an image for a pie. Readily, when you grab an x86 box, generally speaking, you just take EVE-OS, you get it from GitHub, you plug it in, and it's gonna run. Generally speaking, you might run into issues, you know, because like, you know, cell drivers, you know, always a challenge in the Linux world, because it is rooted in Linux, but it's got the embedded hypervisor, watchdog timer, stuff like that. But just foundationally, it'll run. So whether you get a Raspberry Pi or a NUC or otherwise, but again, this is the benefit of creating an ecosystem around it. The hardware providers are starting to even upstream drivers for it. You know, and so that's the ultimate goal, is like literally make it a factory OS, because it's a universal option, and then you don't have to think about it. So to get started, so it's you know, we can get you hooked up with the you know, the code in the GitHub and some getting started stuff. FYI, so there is again the open source controller within the project. We're about to launch, you know, from a Zadita standpoint, a dev program. Where you can actually get to the cloud UI that uses those open APIs. That's makes it even more usable, and we literally have K3S, you know, in there, and you can just click a button and deploy it. And so we're going to do invite only alpha version of this developer program here shortly. So if you guys, you know, want to get access to that, you know, let's talk, because then, you know, we can kind of give you the easy button, you know, as part of that invite only phase, and then we're going to make it automated in the future. But you know, again, that's just because most developers do not care about security management up front. They want to get to hello world and some app. And what we see all the time is people are like, oh, I don't understand what you guys do. I don't understand the value of this or whatever. And then after they actually try to deploy something in the real world, they're like, okay, now I really understand it. And so that's why we want to get people access, the ability to get bootstrapped, develop your app, you know, do whatever you need to do, but then don't have to reinvent security management after the fact. Because this goes down to silicon, measure boot, remote attestation, all the bells and whistles.
Yeah, I think
so
this
long story
group in
short,
particular would be interested in kind of that, you know, directed path for a proof of concept that would take you
we can
into
help
a
with that.
Kubernetes hosted version, obviously, since this is a Kubernetes thing, and maybe with the assumption that they didn't have to think about it, but it ended up kind of default secure out of the box.
Yep, that's the whole goal. I mean, this is set up, especially, I mean, you know, again, anyone could build the controller, but the way that we've set it up is like, you don't need to know a lick about IT to deploy a box and just, you know, out in the field, because usually it's a very different skill set, as you guys know, once you get out of the data center. So yeah, so we can get you kind of set up with some of that, and sort of bill it as, you know, a POC. You know, again, it's sort of like that early alpha dev program. And then we're going to do sort of like this rolling thunder as a community, bridging to other kind of popular application communities. So first it's Kubernetes. That's going to be the first push to the broader Kubernetes community. Hey guys, if you're deploying Kubernetes out in the field, you're going to need some sort of foundation to make it secure, to be able to manage the hardware and all that. So that'll be phase one. Then we'll start attaching it to other things like, you know, your TensorFlows of the world, and you know, other types of application stacks, you know, the EdgeX and Fledges and stuff like that. So, but Kubernetes being the first priority. So yeah, we'll get you set up. I'll send you this deck. We'll get you guys set up. You know, I'll just send it, but you know, I don't know, Roman and Eric, any that work for you guys? Just kind of get the team hooked up to
yeah, totally. I just one last thing that I wanted to point out is that LFEdge is actually a place where we host Acrano. And Acrano is in business of producing these blueprints, which is basically industry-approved, you know, approaches to various use cases. So there's a few blueprints, you know, involving Kubernetes, obviously, and how it, you know, gets deployed in various, you know, edges that Jason talked about. It would be interesting, I mean, to sort of maybe for you guys to kind of like take a look at those and see what you know, think, or maybe there's some of the cross-pollination between two of the communities, because, you know, it's sort of always useful for the other side to know it's like what the other side is doing, you know.
Okay, just a time sync warning. You can have about 5 more minutes. Same to anybody with questions. Go jump in and get your questions in now.
One thing I wanted to point out before it closes is, yeah, Aaron posted some links in the chat for this, and once it's over, the chat will disappear. So if you want to click on those now, it would make sense in terms of how to hook up with the EVE community and pointers at the Slack channels and whatever in there and our meetings. So.
I also put the main links in the document that it gives the intro for you guys. Also, what to kind of go on to what Roman was talking about with Arcano, there is also some work trying to implement LFEdge, so that could give you another reason to go into that, and so just as a FYI.
Well, any other?
I was gonna say, if you guys have more questions about EVE or you go play with it today, tomorrow we do have open office hours, so they're at 8 a.m. Pacific. So please join us. I think I put that link in there too, but that's pretty easy to find. And you can always, if you have any questions, shoot us all an email or go on our Slack.
Yeah,
Okay, and I
one-
cut the
one-
office hours
the
link
meeting
into the
notes.
agenda notes if anybody's watching this later on YouTube.
And I'll drop a little bit of a teaser, since we're going to do this kind of rolling thunder thing around. It's on April 22nd. Is part of the reason to reach out is, can we help at all, like just in terms of that foundation. But as we kind of roll this out, I'd like to kind of make it known in some press that we're collaborating and helping build out the vision that you guys have been growing and all that. So just something to think about, but just as a
Okay,
as a
and feel
milestone out
free
there.
to promote that. I mean, we
Yeah.
allow anything on open source projects, not
Yeah.
it's not a sales pitch channel, but go ahead
No,
and
no,
use
we-
the Slack channel to remind people
Right,
of
we
that
would-
event.
Yeah, we would have to keep the commercial component, separate, and maybe do a blog or something. But yeah, definitely aware of the sensitivities around that. Cool. I got to run as well, but thanks for the time. We'll send all this stuff off if anyone wants to tinker. I mean, actually, you can go to GitHub, but if you guys want to get access to some other stuff, like the easy button side, let us know.
Okay,
And,
thanks
we'll
for
go from there.
doing this. It was a great presentation. If there's anything you didn't have time for or think about later, feel free to just throw it in the agenda notes document for links later, particularly things related to Kubernetes integration.
Right.
Our meeting in 2 weeks on the APAC Europe cycle tentatively has a speaker on a new project called OpenYurt. I don't know that much about it myself. I'm looking forward to it, but I get the impression that this is something along the lines of a LFEdge that is a extension to Kubernetes to support some edge use cases. And it is now recently became a CNCF sandbox project. So that would be on the April 7 meeting. For those not familiar with this group, we alternate times. So this is the North America time cycle, which comes out to be 9 a.m. Pacific. The alternate cycle was done to make it easier for membership in Asia and Eastern Europe. And that one in my time zone tends to be 10 p.m. or 9 p.m. at night, depending on how daylight savings time intersects.
Yeah.
Does anybody else have any last remarks, questions, comments? Okay, I'll take silence as no, and we'll declare this meeting over. I'll end the recording, and thanks everybody for coming. If that OpenYurt presentation on a new Kubernetes extension for Edge appeals to you, maybe we'll see you in 2 weeks, and thanks for coming.
Yep, thanks again for having us. We'll catch y'all later.
Yeah.
All right.
Thanks.